Today, lesson 17b, the distributive property and combining like terms with rational numbers. This would be the third time this year that we've returned to the idea of the distributive property, and after using the distributive property in some problems combining like terms. Today the focus, though, is on positive and negative fractions involved within these types of ideas. So today you'll be simplifying expressions using the distributive property with rational numbers, our focus being fractions, and state distributive property problems correctly. And then, as usual, we have a why am I learning this? All right, so let's go ahead and get started. A little bit of background knowledge. Remember to use the distributive property. We multiply the number on the outside by everything within the parentheses. We would state that original problem as 5 times the quantity of x plus 3. And when we multiply that out, we end up with 5x plus 15. Or this one, we would have to use the distributive property first, and then sometimes after that, we have to then simplify it by combining like terms. As usual, I'm using shapes to highlight my like terms. And then sometimes we have to use the distributive property more than once and then combine like terms. Well, we've done this once with integers, like here. We've done it again with positive and negative decimals. Today's the third time where we now involve positive and negative fractions. I don't know that I should have to explain how to do this, but everybody go ahead and simplify that using the distributive property. All right, using the distributive property, we've got 1/2 times x. Now, typically before today, when we've used the distributive property, we've done a lot of stuff in our head. And sometimes we can continue with that when we have fractions involved, but a lot of times we need to really think about what's happening. So right here, we have 1/2 times x. And then subtract, now it's 1/2 times 8. And the reason why I'm starting to going back to showing steps again is because as the numbers get more complicated, the result from the product ends up taking a little bit of work. So obviously right here, this is 1/2 x. And then we have this issue right here where some of you may have to, off to the side, do a little bit of work to figure out that that part right there is 4. And so 1/2 times the quantity x minus 8 is 1/2 x minus 4. And if you did not get that, fix it as usual. All right, so once again, 1/2 times x is 1/2 x. 1/2 times 8 is 4, so we end up with 1/2 x minus 4 for the simplification using the distributive property. Everybody try number 2. So number 2, we're going to multiply 3/5 times 5x. Once again, when we did integers, most of you could do these in your head very quickly, but now that we're involving fractions like we did with decimals, you're going to need to show the steps so you know what happens there. And then we have to multiply the 3/5 times the 15. And here's where, if you can't do this part in your head, then perhaps off to the side, what we need to do is multiply 3/5 times 5/1x. And we can see that that part right there gives us 3x. Same thing here. If you can't do 3/5 times 15 in your head, then perhaps somewhere off to the side, 3/5 times 15/1. Do a little bit of cross dividing, and we can see that that part gives us 9. So Chris was correct. The simplification there is 3x plus 9. Any questions with number 2? All right, here's what I want. I want everybody to do number 3 and number 4, and then we will compare what we have with our shoulder partner. Once again, do both number 3 and number 4. Number 3, first of all, we have 3/4 times 8x. If you can't do that part in your head, then somewhere off to the side, something like this. Do a little bit of cross dividing, and we can see, or we should see, that we end up with 6x for that part right there. Now the second part. 3/4 times 2/3. And fortunately, I don't need to do that one off to the side. I can just do this one right here. Do a little bit of cross dividing here, and I end up with 1/2. So for number 3, we should end up with 6x plus 1/2. Any questions with number 3? Okay. And I'm just going through the steps here one more time. And then number 4, same idea. We're going to multiply 5/8 times 8/3 x, and if you can't do that in your head, then you should maybe off to the side, or I guess in this one we could just do this if we wanted to. But we can see that we end up with 5/3 x. Now that's going to bring me to another part of the discussion here in just a second, but let me finish the second part here. We have 5/8 times 1/7. I can't do any cross dividing there, so now I can multiply straight across. Now, I saw some of you with this answer right here, but I saw others with this, 1 2/3 x minus 5/56. Is the 1 2/3 x minus 5/56 okay? Yes or no? Sure. 1 2/3 x is equivalent to 5/3 x. This is actually the preferred way of writing it as we get to higher math courses, but this is just as good. Yes?
Why 5/3?
Just because it looks less messy. It just looks kind of funny with that letter sitting right next to the 1 2/3, right? This looks a little cleaner, 5/3 x minus 5/56. Plus, next year when you start graphing these sorts of situations, the 5/3 is a little easier to deal with. Okay? All right, so let me go ahead and finish this one up. And notice that I left it both ways there. Okay, so let's take a look at number 5. Now we get to a situation where we're going to have to use the distributive property twice and then combine like terms. So here's what I want you to do for number 5. I want you to go ahead and do both distributive property parts and then stop. In other words, I want you to do the distributive property here, and then I want you to do the distributive property here. I want to make sure we're all okay with that part before we move on. So go ahead and do the distributive property on both parts and then stop. All right, so number 5, we had done the first part of it, but it's really the same thing. You're just doing each part independently and then from there combining like terms. We already talked about how this and this simplify to 3x plus 9. We do a little bit of cross dividing to get there. And then we do the same thing here and here. But that would leave us with 3x plus 9 and then plus 4x minus 2. And then from there we just combine like terms. Positive 3x, positive 4x gives us positive 7x. Positive 9 and the negative 2 would give us 7x plus 7. Number 6, same idea. Here we end up with 1/3 times 9x, which ends up being 3x. If you're not sure how I got that, put a 1 underneath and do a little bit of cross dividing. You can see how that's 3x. We do the same thing right here, 1/3 times 12. If it makes you feel better, put a 1 underneath of the 12 and then do some cross dividing, because at that point you're just multiplying fractions. And then we do the second part of the problem. But we should end up with 3x minus 4 plus 3x minus 6. Positive 3x makes positive 6x. Negative 4 and negative 6 makes negative 10. So any questions with number 6? When I walked around, most of you did get that for the simplification. Okay? All right, we've got one last thing to talk about today, so let's go to the back side. And it involves an idea that we talked about last week. And that's the fact that sometimes you have fractions and decimals within your expression. And we talked about we could convert to all of them to decimals or all of them to fractions. The problem with converting to decimals is, what do we do if when we convert it we end up with a repeating decimal? That can lead to some problems for some people. So let me just show you, and this one's all worked out in your notes, I know. But that's what it would look like if you converted it all to decimals. And you can see right here, we've got a problem right there and a problem right there. Because how are you going to add those two things together? Well, it can be done. It's just a little more complicated. My advice is to convert everything to fractions. So we talked about that 0.4f is 4/10 f. And we talked about the minus or subtract 0.2 at the end is subtracting 2/10. And then if we reduced both of those, and what I'm talking about is this was 4/10 f, it reduces to this. This is 2/10, which reduces to this. From there, we just have to do essentially what we did in the last problem, combine like terms. So my advice is to convert to fractions if you have decimals and fractions within your problem. Now, these two things are the same. They are equivalent to each other. But I think for most of us in here, converting to fractions is a little easier to deal with. So, let's go through number 7 together, and then I will have you try number 8. All right, so first thing we should do in number 7 is convert this to an improper fraction. What is that as an improper fraction? 6/5, good. And then we have 5x plus 8. Now, we've got to convert this. Remember, we think that converting to fractions is a better strategy. So what are we going to turn 0.9 into? 9/10. Good. 9/10 is equivalent to 0.9. Now, we have something that we just talked about in the last problem. Okay? And I think I'm going to just go ahead and finish this one for you, and then I'll have you try number 8. So let me take this off. And what I'm doing here is I'm doing the multiplying out and converting at the same time. So this times this, we can do a little bit of cross dividing. That's 6x. This times this, we can't do any cross dividing. That's 48/5. Now remember what I said earlier. In an earlier problem, I said that that's just as good as a mixed number when we're doing these types of problems. Here, we can do a little bit of cross dividing. But that ends up being 27x/5. Where did I get that? 9 times 3 is 27. 5 times 1. And then we've got the x off to the side there. And then I guess I forgot to write down this part right here. That's 9/10. And that, actually, it's minus, not plus. And then that would be times 3/1. Can't do any cross dividing. So multiply straight across. And I end up with this. Now, could you convert 48/5 to a mixed number? Yes. Could you convert 27/5 to a mixed number? Yes. Could you convert 27/10 to a mixed number? Yes. But in this kind of problem, we don't really need to. So let me finish it through the lesson here. And notice that I went ahead and converted after I found common denominators. Okay? All right, I want all of you to try number 8, same idea. One of the things I liked when I walked around, I saw some of you, you went ahead and you did this. You went ahead and you multiplied this times this just to see if it ended up being a decimal. And of course it doesn't. 4 times 1.5 is 6. So 4 times 1.5x is 6x. Now right here, we do have 4 times 3/5. Now we have this part, and I'll deal with that in just a second. But this part right here, 1 and 3/5 is 8/5. So now it's 8/5, and that's plus, times 2x. And if you want to put that over 1, go for it. And then we have 8/5 times 5. And if you want to make the 5/1, that's fine. But notice that I didn't even need to convert the decimal to a fraction. You could have, but you didn't need to. So let's finish this off here. We have 6x, and I can't do any cross dividing here, so multiply straight across. I can't do any cross dividing here, so I have 16/5 x, and I can do some cross dividing right there. That's plus 8. Any questions so far? Now we have to combine like terms. So I have to figure out what 6 plus 16/5 is. So that would be 6 over 1 plus 16 over 5. Multiply top and bottom by 5 there. So I end up with 30 over 5 plus 16 over 5. That is 46 over 5. Question, can I leave that as 46 over 5? Yes or no? Yes or no? Yeah, I wanted to be a little more clear. Yes or no? Yes. Yes, you can. In this kind of problem, you can leave it that way. Now, I have to deal with this. And I'm kind of running out of room on my screen here, so I'm going to do a little bit of erasing to free up some room here. I've got negative 12/5 plus 8 over 1. I have to multiply top and bottom by 5 to have my common denominator there. And I have negative 12. I'm going to erase a little more here. Negative 12 plus 40 over 5. And that is 28 over 5. And I can leave the 28 over 5 like that. Now, if you wanted to convert, I'm going to take this off the screen because I believe the answers that I have here are in the form of a mixed number. But you don't necessarily have to do that. But let me click through here really quickly. And you will see that we end up with something that represents exactly the same thing. This is the same thing as 46 over 5x. And this is the same thing as plus 28 over 5. Both of these two things are equivalent to each other. All right, we are finished. You have tonight's homework.